Today we're going to talk about a new method for integration called integration by partial fractions. Now yesterday's method, which was integration by parts, which rule did it undo? Product rule. Okay? Use substitution undoes chain rule. Integration by parts undoes product rule. This one is a kind of an undoing of quotient rule, but even more so, it is an undoing of chopsticks in a bowl. Now that is a term that is probably only my class's understanding. People who watch this video and are not in this class probably have no clue what I mean by chopsticks in a bowl. So let me stop real quickly and I'm going to go to paper and explain to everybody else watching what chopsticks in a bowl is. So let's say you have 3 over x minus 1 plus 5 over x plus 4. Chopsticks in a bowl is a method by which you can add those two fractions without getting common denominators. These are the chopsticks, this is the bowl. And what it is you multiply diagonally right here, which is 3 times x minus 4, x plus 4, plus, because the problem is addition, 5 times x minus 1 over x minus 1, x plus 4. This is the representation of the bowl. Then what we do is we distribute 3x plus 12 plus 5x minus 5 over the denominator, which then cleans up to be 8x plus 7 over x minus 1 and x plus 4. Okay. Now, I'm going to go ahead and multiply out. When we used to do this in class, I told you not to multiply out the bottom. Agreed? So if I multiply out the bottom, I get this. Now, I have a fraction. If I had to integrate that, is the top the derivative of the bottom? No, it's not. So I can't integrate it like this. However, I can integrate it like this, because that right there is the top the derivative of the bottom. Well, not exactly, but I could move the 3 out and make it the derivative of the bottom. Does that make sense? Yes. Okay, what would this turn into? What kind of an integral? When I integrate this, what would it be? It would be ln. Because what would happen is that u would be x minus 1 and du would be just what? 1 dx. I could throw the 3 outside and then I have 1 over u, which is ln. Okay? So when it's all one fraction, I can't do it. It is like a dv over a u. But if I separate them, then I can, and it turns into ln. So what we're going to learn how to do today is to start here and go backwards. Turn it from the combined fraction into individual so that we can integrate. Okay? So let's go back to the notes. I'm going to add this in, and I didn't do it first period. Use when the numerator is not the derivative of the denominator. Use this when the numerator is not the derivative of the denominator. That's how you know when to use this method. Okay. There are 2 ways to break that single fraction into its 2 parts that it came from before they did chopsticks in a bowl. There's a hard way and there's an easy way. What I want to do is just kind of walk you through the harder way, which is given in the box at the bottom of this first page. So let's just kind of look at it. We have an integral right here, and we need to take this fraction, we need to break it back into its 2 parts. Well, the first thing we have to do is to factor the bottom and figure out what the 2 parts were as far as their denominators go. And we have to do that no matter what. So x squared plus 3x minus 10 factors into these 2 right here. So what we do is we put them into separate fractions, always with a plus in the middle, and just put an a and a b on the top. We don't know what those numbers are yet. Okay? Now, if you multiply both sides by x plus 5, over here, those are going to cancel, agreed? And that leaves this. Here, the x plus 5 will cancel this x plus 5, leaving just the a. And then here, it's going to throw an x plus 5 on top. Okay, so this is just a rewrite of that original problem. Then, we plug negative 5 in for x, and the reason we do it makes the b go away. Because if we put a negative 5 right here, that's going to make b equal 0. And so then you do the math on the other side, and you find out what a is. Then you do it again, you go back over here and you multiply both sides by the other factor. And do you see how much writing this is? It's a lot of work. And those cross out, it leaves you this. Those cross out, it leaves an x minus 2 on top here. You plug in 2 and you find the b, and then you can create your two separate fractions right there. But it's so much writing. And so there's a much easier way to do this that I'm about to show you. So I just kind of wanted to show that this was the hard way, and now we're going to go to the easy way. So please turn to the back of this page. And I'm going to go very slowly through this. This is actually called the Heaviside Method, and the man who invented it, the mathematician, his last name was Heaviside, so he got the credit for it. Now, somebody developed a quicker way to do this, and it's really, really helpful. So, do the same thing to start. We have the numerator, we factored the denominator, write your two fractions, but leave them empty on top. Okay? So what you do is you look at your first fraction, and you ask yourself, what would cause the denominator to equal 0? What number would that be? Negative 5. Okay, keep that number in your head. Go back to the original left-hand side and cover up this factor. Now plug in negative 5 for the remaining x's. So if I plug negative 5 into the top, that would be 8 times negative 5 is negative 40, plus 82, which is 42, over negative 5 minus 2, negative 7. What does that reduce to? That is negative 6, and that's the top number right there. See, I did it all in my head. Okay? Now we do the same thing for the second fraction. What would cause the second fraction's denominator to be 0? 2 would. So now we cover up the x minus 2. If we don't cover it up, the bottom's going to be 0. You follow me? Okay, now we plug 2 into the top and bottom. So 2 would be 16 plus 82, which is 98, over 2 plus 5 is 7. Okay, you math people who could do math really well in your head, 14. That's 14. So now we got the same two numbers here that they got on the front side of the paper. And now I have undone the chopsticks. If you do chopsticks to this, you're going to get that. And it works every time, okay? You may be thinking, oh, you went a little fast there, Miss Belt. We'll do a problem where you have to write everything down. We'll do several so that you can get the hang of this, okay? So let's jump down to number 2. We're going to do this one together. So I want to find the integral of this. So when you see a fraction, always check and see, is the top the derivative of the bottom? Is it true in this case? What's the derivative of the bottom? 6. If I multiply the top by 2 to make it 2x, is it going to make this last number a 6? No. So it doesn't work. It's a dv over a u. Okay? So what we're going to do is we're going to, first of all, factor the denominator. Now we've got to get our algebra brains on again. How does that denominator factor?
X minus 5, x minus 1.
X minus 5, x minus 1. Please mark out the original problem, because when you start plugging the numbers in, you don't want to try to accidentally plug it in there. So now we're going to move down. We're going to draw an integral again. We're going to have one fraction bar to the x minus 5 and another fraction bar to the x minus 1. Now you can put those in parentheses if you want to, but you don't have to. Okay? Now, let's talk through the procedure one more time. Look at the first fraction. What would cause this denominator to be 0? Positive 5. So go up to the top, cover up that factor, plug in positive 5 for both the x's. What's the top going to be? 1. What's the bottom going to be? 4. So since we got a fraction, we're going to write the entire fraction on top of our fraction in the integral. Okay? Now, same procedure with the second fraction. What would make this fraction 0 on the bottom? 1. So we go up, cover up the x minus 1, plug in 1 for what's left. So that would be what? Negative 3 over negative 4, which is positive 3/4. Don't forget the dx at the end of the problem. Okay? Now, we are going to treat this as two separate integrals. We're going to do each one individually. Okay? Now we have to double check ourselves. What is the derivative of the bottom? 1. So I don't really need this 1/4, do I? I need a 1 there. So what can I do with the 1/4? Easier than that. How about you just move it outside of the integral? Think about it that way. It's a little bit easier to think of that way. So we don't have to change it. We just get to get rid of it. So what we're going to do is we're going to have the 1/4 outside of the integral. So then you would have 1 over x minus 5. Is that a form of an ln? It's a du over a u, isn't it? So it's going to just be 1/4 ln absolute value of the denominator. So that's the answer to the first part of the integral, without writing down all the u's and the du's. Now plus. What's the derivative of the bottom of the second fraction? 1. So do I really need this 3/4? No. So write it out front. Once the 3/4 is out of the picture, is it going to be an ln again?
Yes.
Yes, because the power on the bottom is 1. So ln, absolute value of x minus 1, plus c, and we're done. Questions? Yes.
That's like, that's it. There's nothing else.
There's nothing else you have to do. If you take the derivative of this, and then you're going to have two fractions, and then do chopsticks in a bowl to those fractions, you'll end up right back here. Okay? That's what's happening. Anybody else have a question? Okay. Do you think you could do one of these by yourself? Yes? Okay. Some of you are saying no. Try the next one by yourself. Just do as much as you can. Work together with people sitting next to you. Don't try to do number 4. Just do number 3 for now. We'll do 4 together. First thing, back to the bottom. Back to the bottom. See what you can do. Okay. Are those the two numerators that you got? 2 over 9 and 2 over negative 9. I don't care where the negative goes. And once again, each of these are ln's. So this would be 2/9 ln absolute value of x minus 5. Now because the next fraction is negative, it's really like putting a minus sign as your next sign. 2/9 ln absolute value of x plus 4 plus c. I'm going to show you something that you need to be aware of, and we're going to come across it again later. If the two numbers in front of your ln's are the same, many times on the AP test, they will combine the ln's into a single one. Now, forget that their 2/9 are there right now. If it's subtraction between two ln's, what does it become when you condense it? Division. So this is the same thing as 2/9 ln absolute value of x minus 5 over x plus 4 plus c. Yes, ma'am.
Whenever you turn it into a fraction, does the first one always go on top of the second one?
No, the positive one always goes on top of the negative one. Because we're going to do one in a minute where it comes out to where the first coefficient is negative and the second coefficient is positive of the same number, and you have to then flip them. Okay? So it has to be minus between the two terms. If it's minus between the two terms, it is the first one over the second one. So that's the best way to keep it straight, is just always put it to where it's minus. If it's not minus, switch the terms first and then put them in. Okay? So how are you doing?
Good.
Okay so far? All right, let's look at the last one on this row. What about factoring the bottom of this thing? Number 4. I can take out an x, and what would be left?
X squared minus 4.
X squared minus 4. Now,
Plus 2x minus 2.
on the AP test, you will never see any factors on the bottom with squares in them that cannot be further factored. Everything is going to be linear, powers of 1. So if you ever come across a square, you should be able to factor it again. And Hannah, what did you say this factors into? X plus 2, x minus 2. So I'm going to mark out both previous forms of the answer. So how many fractions is this going to make? It's going to make 3. So we're going to have equals integral a fraction over x plus a fraction over x plus 2 plus a fraction over x minus 2. Remember I said they all get plus signs until you start finding out what those numerators are. Okay? All right. What is the first value I'm going to be plugging in for x? 0. Does everybody understand why it's 0? Okay? So we go up and we cover up this x and plug 0 into the top. What's that going to be? 12. 0 into the bottom, be careful, that's going to be positive 2 times negative 2, which is negative 4, which reduces to negative 3. So negative 3 goes there. Okay, what about the second fraction? What should I plug in for the second fraction? Negative 2. Okay, so I'm going to cover up that middle thing. So negative 2 squared is 4. Minus 24 is negative 20, plus 12 is negative 8. Divided by, what am I plugging in? Negative 2 times negative 4. No, I'm multiplying, positive 8. Negative 2 times negative 4 is positive 8. What does that reduce to? Negative 1. Check my math. Mental math is not my strong point. Now, if you're doing this and you're going, I can't keep all this straight in my head, I need to write more down, write it down. That's fine. Okay? What about the last fraction? What do I plug in for that? 2. So cover up that last factor. 4 plus 24. 28 plus 12 is 40. Over, I'm plugging in 2, so 2 times 4 is 8. What's 40 over 8? 5. Throw the dx on the end. Okay. Now notice that all of the factors on the bottom are just x. X plus something, x minus something. That means they're all going to just be ln's, and you bring the coefficient that's on the top down in the front. So I'm going to come down here because I'm running out of room. Negative 3 ln absolute value of x minus 1 ln absolute value of x plus 2. The 1 is not needed, but the minus definitely is. Plus 5 ln absolute value of x minus 2 plus c. Questions? Starting to get the hang of it? Of this breaking it apart? Okay, let me ask you a question. Let's go back to, say, this middle one. Before I take the antiderivative, how can I make sure that those two fractions are right? Just go back and do chopsticks to the two fractions, and it should end up back where you started. Do you agree with that statement? If I take these two and do chopsticks, I should end up with this. Then how can I make sure my answer's right? Take the derivative of this and then combine your fractions and see if you end up back where you started. Okay? So it's chopsticks, undo chopsticks, and then antiderivatives. All right. Now, please look at number 5. And this is going to go back, and I had to do some review with my first period class, probably will with you too. What do you notice about number 5's problem compared to the other ones that we've done so far?
There's a lot more on the top.
There's a lot more on the top, and it's not just more, it has a higher power. Do you see that?
Yes.
Okay, everything we've done so far, the bigger power has been on the bottom. It's been x squared on the bottom and an x on the top, right? But now it is flipped. The top has a degree of 3, the bottom has a degree of 2. If this happens, you have to do long division of polynomials in order to change its form. Now, some of you are going, I don't even remember how to do that. And that is fine. We're going to do a refresher course. So let's write the problem first, which is, which of these two things goes on the outside of the division bar? The bottom does. X squared minus 6x plus 5 goes outside. And then x cubed minus 9x squared plus 24x minus 17 goes inside. And some of you are shaking in your boots going, I don't know how to do this. When did you see this? Algebra 2, probably? That fast. Okay. So, let's take this back to something you do know how to do. Okay? Now, I'm going to pull this aside and go back to notebook paper, and I want you just to watch. Okay? Has everybody copied the problem down?
Yes.
I'll wait just a second. Okay? So now, go back to notebook paper. Let's take a regular problem. 24 into 683. Regular division. How do you do it? 24 into 68, but even more simply, 2 into 6. Would you agree with that statement? That's kind of a good place to start. How many times does 2 go into 6? 3 times. So let's see if that works. 24 times 3, 12 carry 1. That's 72. Too big. So 2 should work, right? So you write a 2 up here, and then what do?
Subtract 2 times 24.
Multiply 2 times 24 and write it here. That's 48.
You subtract 2 times 24.
Yeah, you multiply first, and then you subtract. Yeah, you're right. You're jumping 2 steps ahead. So what do you get? 20.
And then carry down.
Bring down the 3. How many times does 24 go into 203? Maybe 9. Let's try 9. 24 times 9. 6, carry 3. 18, 3 is 21. Too big. 24 times 8 is 2, carry 3. 192. Is that better? So we write the 8 here, and we get 192, and that becomes 11. Now, we have 2 options at this point. What is one way we can do this? Put a decimal and keep going.
Put 11 over 24.
But the way we want to do it is to take your remainder and put it over the divisor, so 11/24. Now, these 2 are really added together, aren't they? It's 28 plus 11/24, so we just don't write the plus sign down. Agreed? This is the exact same procedure we're going to do on that X mess. Okay? So let's go back to the X mess. You can do this. I promise. You can do it. Okay? And you'll be surprised how much it makes sense this time and didn't make sense before, possibly. All right? First thing here. What do you multiply an x by to get an x squared by to get x to the third? X. So write an x up top. Okay? Now when we put our number on top of the division symbol, what did we do next? We multiply that number to everything out front. And that's what we're going to do here. X to x squared is x to the third. X to negative 6x is negative 6x squared. X to 5 is positive 5x. So I'll give you a second to write that down. Does everybody see where all that came from? Okay, what did we do next on the other problem?
Subtract.
We subtracted. So when we subtract letters, we change their signs. So where I'm going to go through and change all these signs. The x cubed turns positive, the 6 turns positive, excuse me, the x cubed turns negative, the 6x squared turns positive, and the 5x turns negative. That's how we subtract. Add the opposite. So the x cubes cross out. What's negative 9x squared plus 6x squared? Negative 3x squared plus 19x. Okay. Now we drop down the negative 17, just like we did before. Drop that down. Now we do it again. What do you multiply x squared by to get negative 3x squared? Negative 3. Throw a negative 3 on top. Now we only multiply the negative 3 to the front stuff. So that would be negative 3x squared. What's the next term going to be?
18x.
Positive 18x. And then minus 15. Y'all agree with that statement? Okay, the next step is to subtract. So change all your signs. 3x squared is positive, 18x is negative, 15 is positive. 3x squared is cross out. So what am I left with? 1x minus 2. Okay? Am I done? Well, can I do division again? Is there a way I can divide an x squared into an x? No. So this is my remainder, and we put it over what? The front thing. So we write plus x minus 2 over x squared minus 6x plus 5. So now our problem looks worse, but it's actually better. So copy the answer we just got. X minus 3 plus x minus 2 over x squared minus 6x plus 5 dx. On the fractional part is now the degree of the top less than the degree of the bottom.
Yes.
Yes. Okay. Do you know the antiderivative of just an x?
Yeah.
What is it? 1/2 x squared, right? What's the antiderivative of just a negative 3? Negative 3x. So those two were taken care of. This is now a partial fractions problem. Because the bottom, the derivative of the bottom is not the top, so I got to split it. So what we're going to do is we're going to write the integral x minus 3, and we're going to do it all at one time. I know how to do the first two, but we're going to go ahead and split it first. How does the denominator factor? I forgot to do that first.
X minus 1 and x minus 5.
X minus 1 and x minus 5. So I'm going to write those on the bottom. Okay, you do just the next step. Give me my two numerators. You find my two numerators. Question.
Whatever number it is, do you also plug it in for the first x? The x?
No. Good question. Very good question. She said, okay, I picked 1. I cover up the 1. Do I plug the 1 into the x in front? The answer is no. We're only working with the fraction. We're only splitting the fraction. All right. So we should have gotten 1/4 for the numerator of the first fraction, 3/4 for the numerator of the second fraction. So now we're ready to integrate. So tell me again, what is the antiderivative of x? 1/2 x squared minus the antiderivative of 3. 3x plus, now these two fractions are like the ln fractions we've been doing all along. 1/4 ln absolute value of x minus 1 plus 3/4 ln absolute value of x minus 5. Don't forget your plus c, and you're done. So to recap, when do you have to do this long division?
When the power of the
When the
bottom
power
is
is
greater.
greater.
When the power of the bottom is less than the power of the top instead of greater. When it's top heavy. When the power on top is too big. It's like having an improper fraction. If I said 5 halves, could you make that into a mixed number? You would do long division, 2 into 5, and it makes 2 1/2. It's the same procedure. Okay. Any other questions on when to do this? They don't show up very often, and they are kind of a pain. But when they do, this is what you got to do. Is everybody done writing? Can I move on? Okay. Flip this over to the other side. And it says at the top, we're not going to do all of these, just a couple. First of all, mark out number 10 at the bottom. It's off the screen. That's okay. I haven't taught you the procedure to do that yet. It's called differential equations, and that's our next unit after this. But we can do number 6. And it says, sometimes we can use a substitution in order to integrate expressions that do not seem integratable. So if you look at the first one, it kind of looks like what we've been doing, but instead of x minus 1 and x minus 6, or x plus 6, we have e to the x minus 1 and e to the x plus 6. So what we're going to do is we're going to actually do a u substitution that's a little bit different. So if the problem looks something like this, u is not the denominator, u happens to be this time e to the x, because I wanted to say u minus 1, u plus 6, and then I can use the partial fractions on it. Okay? So if u is e to the x, what is du? E to the x dx, which is this. There's my du. Okay?
So that's your
That's my du, yes. So the two e to the x's on the bottom are going to turn into u's. So now I'm going to have the integral. This e to the x dx is du, so I'm going to write it out to the side. And then these are going to be u minus 1, u plus 6, and what on top? A 1. Okay? Do you see now that this is the kind of problem just like we've been doing all along? The bottom's already pre-factored for you, so what we need to do now is break it into its two fractions. So we have one fraction with a u minus 1 plus one fraction with a u plus 6. So what do we plug in for the first numerator? 1. So we're going to cover up that. We're going to have 1 over 7. So 1 over 7 goes there. Negative 6 for the next one. So it's going to be 1 over negative 7. Agreed? Remember to cover up the factor when you plug it in. dx needs to be on here. Now, if you forget to write a dx on the AP exam, are they going to really ding you for it? The answer is no. Will I ding you for it? Maybe.
Yeah.
Maybe. So write them down. So this will now be, we're ready to integrate, 1/7 ln absolute value of u minus 1. Now because this fraction is really negative and it's coming down, it's going to be a minus 1/7 ln absolute value of u plus 6 plus c. Am I done?
No, you have to plug in.
I have to plug back in what u is, and do you also notice that the two coefficients in the front are the same? So what did we do last time when they were the same?
fraction.
Make it into a fraction. So I'm going to do that. So I'm going to get my other color and do both things at the same time. So it's this 1/7 ln absolute value of e to the x minus 1 over e to the x plus 6, close it, then plus c. Questions? So if the bottom looks like something that might break into undoing chopsticks in a bowl, Just make u that thing, like u the x was this time. All right? Okay, we're going to do one of the application problems at the bottom. We're going to do number 8. This says find the area. We know how to do this. Okay? But this is the first time we've done a definite integral with this procedure. So we're going to do that. So, if we're going to find area, it's either top minus bottom or right minus left. Can we draw all rectangles to hit the curve on top and the x-axis on the bottom?
Yes.
Yes.
Did you just draw those rectangles?
Yeah, I just drew these in.
That's fine.
And I'm making them like micro thin rectangles. So it's going to be top minus bottom, so that means it's going to be the integral of the top equation, 80 over x squared plus 6x plus 8. The bottom equation is 0, so we don't have to write it down. Dx. What are my limits of integration?
0 to
0 to 4 or 0 to 10?
McKinsey. I don't know.
Do you go up to find your limits, or do you go across?
Across.
You go across because it's dx, and it happens to be 4. So 0 to 4. Okay. The derivative of the bottom is 2x plus 6, which is definitely not on top. So this is a split the fractions problem. How does it factor? Multiply to be 8. 2 and 4. X plus 2 and x plus 4. So we come down, 0 to 4, something over x plus 2 plus something over x plus 4 dx. I'm going to mark out this. It's too much to look at. What do I plug in for the 2? X plus 2? Negative 2. So 80 over, no, be careful, it's negative 2 plus 4. It's 2. What's 80 over 2? 40. 40 goes here. And then plug in negative 4. That's 80 over negative 2. Negative 40. Now, it happened to be in this order because of the way I put the denominators. Sometimes they're switched. Okay? So, we now have 40 ln, absolute value of x plus 2 is the antiderivative, minus 40 ln, absolute value of x plus 4, back bracket, 0 to 4. This is the first time we're not going the plus c road. We're going the evaluate the definite integral. Okay?
So you wouldn't write it like a fraction?
I'm about to. I'm going to tell you right now that if you write it like a fraction, it makes plugging in the numbers a lot easier. When I did it the first time, I didn't make it in a fraction, and it was a lot more math to do to clean it up. So, since I'm running out of room, I'm going to come up here and write 40 ln, absolute value of x plus 2 over x plus 4, bracket 0 to 4. So we're going to have, which one do we plug in first again? 4. So 40 ln of, now that we're plugging in numbers, if they come out to be positive, you can write them in a parentheses now instead of in a absolute value. So 4 plus 2 is 6, 4 plus 4 is 8. So I can change it to a parentheses if I want to. If you chose to leave it in absolute value, that's fine. But you don't have to do the absolute value anymore. So 40 ln of 6 over 8 minus 40 ln of 2 over 4. Now once again, I have 2 ln's subtracted that have the same leading coefficient, don't I? So I can make this one into a fraction to clean it up. So this would be 40 ln of 6/8 over 2/4. Now I know I did not reduce those. I'll reduce them when I'm done. How do you divide fractions?
Multiply the second by the reciprocal.
Keep, change, flip. That's one thing I've heard. Multiply by the reciprocal, but the reciprocal of which one? The denominator. And there's a little rhyme that goes along to help you remember how to divide fractions, and it goes like this. When dividing fractions, it's easy as pie. Just flip the second and multiply. So, when dividing fractions, it's easy as pie. Just flip the second and multiply. And that's what we're doing. So, I'm going to come over here and do 6/8 divided by 4 halves, or multiplied by 4 halves. So that's 24 over 16, which can both be divided by 8.
3 halves.
So it's 3 halves. So it's 40 ln of 3 halves is my answer. Yes, sir.
Oh, will it always be ln?
Yes, it will always be ln, because you're turning the numerator into a constant, and it's a constant over a linear x, which is always ln. Okay?